Hi there, welcome back to Three Inquisitive Kids. My name is Karen, and in this lesson, we will be using our knowledge of parallel lines comprehensively to prove the parallelism between two lines. Now, as we proceed into this lesson, you will see that there are some places where I tell you to pause and take notes. So these are often going to be at points where it says observe and think, review, or conclusion. So if it says any of those headers, or if I ask you to, it's probably a good idea to pause the video and take notes, because those notes will later help you a lot when you're trying to solve problems. So that leads me to my second point here, which is when we're doing problems, I would like you to pause the video and try to solve it on your own first. This will give your brain the challenge it needs in order to fully understand the concept we're going for. Anyways, without further ado, let's get into the lesson. This is part 2 of our lesson, Properties of Parallel Lines. Part 1 was all about the different properties of parallel lines, including angular relationships and linear relationships. Now we're going to use all the information we learned from the last lesson and apply it to problems. So in this lesson, we're going to be doing lots of practice problems where we have to prove that two lines are parallel. Today we're going to further grasp the properties of parallel lines and the use of two straight lines to judge whether angles are equal or supplementary. We will also be able to perform simple reasoning and calculations based on the properties and judgment of parallel lines. Observe and think. 1. Proving parallel lines. In the last lesson, this is what we learned. If angle 1 is equal to angle 2, then A is parallel to B, since corresponding angles are congruent. If angle 3 is equal to angle 2, then lines A and B are also parallel, because alternate interior angles are congruent as well. And if same-side interior angles are supplementary, then A is still parallel to B. So these are the two main conditions that we learned about in the past lessons of this unit. Again, if you haven't had this down from the previous lessons yet, I very much recommend you to do so right now. Anyways, let's move on to point 2. Other ways of proving parallel lines. As shown in figure 1, if A is parallel to B and C is parallel to B, then A is parallel to C, because two lines that are parallel to the same line are parallel to each other. And as shown in figure 2, if A is perpendicular to B and A is perpendicular to C, then B is parallel to C. Two lines that are perpendicular to the same line are parallel to each other. Finally, properties of parallel lines. Here, all of our given conditions are that A is parallel to B. And what differs this from point 1, where we talked about the conditions of parallel lines? It's different because here we already know that the two lines are parallel. But in point 1, here, we don't know that these two lines are parallel yet. So in point 3, it would be because A is parallel to B, then something, something. But here it's because something, something, then A is parallel to B. The order of the cause and effect matters. Anyways, back to point 3. All of our given conditions are already that A is parallel to B. So this is what the figure looks like, and this is the type of angle relationship. So if A is parallel to B, corresponding angles 1 and 2, are congruent. When two lines are parallel, corresponding angles are congruent. Same thing for alternate interior angles. And here, as shown in the figure, angles 3 and 2 are alternate interior angles. And if A is parallel to B, we know that angle 3 is equal to angle 2. And for same-side interior angles, when two lines are parallel, same-side interior angles are supplementary. So here, angles 2 and 4 are same-side interior angles. And if we know that lines A and B are parallel to each other, we also know that angles 2 and 4 add up to 180 degrees. Applying the properties and determination of parallel lines. Answer the following questions according to the figure, right here. If angle 1 is equal to angle 2, which lines can you prove that are parallel? Explain with reasoning. I want you to use your knowledge of the properties and conditions of parallel lines in order to solve this question. When you're done answering, resume the video and we'll look at the answers together. Alright, so here's the solution. Angles 1 and 2 are alternate interior angles, as we can see in the figure. If angle 1 is equal to angle 2 using the criterion is just another word we use for condition. So using the criterion, two lines are parallel when alternate interior angles are congruent. Therefore, we know that EF is parallel to CE. So the two lines that we can prove are parallel would be EF and CE. Here are two more questions. If angle 2 is equal to angle M, which lines do you know are parallel? And how do you know? Question 3 is, if angle 2 plus angle 3 is equal to 180 degrees, which lines are parallel? And how do you know? Use the notes you've just taken from our introduction to help you answer these two questions. Alright, so here are the two answers. Angle 2 and angle M are corresponding angles, as we can see in the figure. If angle 2 is equal to angle M, according to the condition, two lines are parallel when corresponding angles are congruent, we know that AM is parallel to BF. And for the third question, angles 2 and 3 are same side interior angles. If angle 2 plus angle 3 is equal to 180 degrees, according to the condition, two lines are parallel when same side interior angles are supplementary, we know that AC is parallel to MD. Let's do another problem. As shown, AB is parallel to CD. If angle 1 is equal to angle 2, then is EF parallel to AB? Explain. Again, I want you to pause the video and try to solve this on your own first. Well, because angle 1 is equal to angle 2, according to the condition, two lines are parallel when alternate interior angles are congruent, we know that EF is parallel to CD. Also, because AB is parallel to CD, according to the condition, when two lines are parallel to a third line, they are parallel to each other. So, EF is parallel to AB. And what's more difficult and more challenging about this question than the last one was that this question requires two criterions in your solution, or two conditions. You really have to first plan out what you're going to say before you write it down. That's what makes this question more challenging. Practice. As shown, so there's 4 things that you want to fill out right here. If angle 1 is equal to blank, then AB is parallel to CE. And you are essentially filling out these blanks and writing down these if-then situations. So let's do it together. If angle 1 is equal to angle 2, then AB is parallel to CE. If angle 1 plus angle 3 is equal to 180 degrees, that's given, then CD is parallel to BF. And the reasoning for this first blank is that two lines are parallel when alternate interior angles are congruent. Angles 1 and 2 are alternate interior angles. Angles 1 and 3 are same side interior angles. And for the second question, two lines are parallel when same side interior angles are supplementary. Here, angles 1 and 3 are same side interior angles, which means that CD and FB or BF are parallel. If angle 1 plus angle 5 is equal to 180 degrees, that's given, then what is parallel to what? Angles 1 and 5, let's first look at their relationship. 1 and 5 are same side interior angles, and they add up to 180 degrees. So using that criterion, we know that AB is parallel to CE. Two lines are parallel when same-side interior angles are supplementary. And finally, angle 4 plus something is equal to 180 degrees. Therefore, CE is parallel to AB. Well, the only condition that uses supplementary angles is when same-side interior angles are supplementary, which means that angle 4 plus its same-side interior angle is equal to 180 degrees. And in this case, that would be angle 3 because it's CE and AB. And yes, although angles 4 and 5 are also another pair of same-side interior angles, here it's asking for CE and AB. Given that angle 3 is equal to 45 degrees and that angles 1 and 2 are complementary, prove that AB is parallel to CD. Again, complementary angles add up to 90 degrees. Let's solve this together. Since angles 1 and 2 are vertical angles, then we know that angle 1 is equal to angle 2. Also, because angle 1 plus angle 2 is equal to 90 degrees, that's given, we know that angle 1 and angle 2 are both equal to 45 degrees. And since we are given that angle 3 is equal to 45 degrees, so we know that angle 2 is equal to angle 3. Therefore, AB is parallel to CD, because two lines are parallel when alternate interior angles are congruent. Angles 2 and 3 are alternate interior angles. And now you'll start to see a common pattern with solving this question. Is you have three conditions, or you have three properties of parallel lines. And sometimes you're given that straight in the problem. You're given angles 1 and 4 are supplementary, and you see that there are same-side interior angles. Sometimes it just gives you that in the question. But when it's not given directly in the question, you want to start thinking what is a way, using the conditions you are given in the question, to make it so that one of those conditions or one of those properties of parallel lines hold true. That is the mindset that you need to have when you're trying to prove that two lines are parallel. Example 3. As shown, given that A is parallel to B and C is parallel to D, and angle 1 is equal to 107 degrees, find the measures of angles 2 and 3. Again, I want you to pause the video and solve this on your own first. Well, here's the solution. Because A is parallel to B, according to the condition when two lines are parallel, alternate interior angles are congruent, we know that angle 2 is equal to angle 1, which is equal to 107 degrees. And since C is parallel to D, according to the condition when two lines are parallel, same-side interior angles are supplementary, we know that angle 1 plus angle 3 is equal to 180 degrees. Therefore, angle 3 is equal to 73 degrees. And we get that by taking angle 1 away from 180 degrees. Class summary. Properties and conditions of determining parallel lines really are based off of two types of relationships. Linear relationships, which is the relationships between lines, and angular relationships, which are the relationships between sets of angles. So two lines being parallel is a type of relationship between lines. That's a type of linear relationship. So angular relationships, the conditions that angles meet or satisfy, determine the linear relationship. And linear relationships have properties that are angular relationships. So when it comes to parallel lines, corresponding angles, alternate interior angles, and same-side interior angles, and their corresponding conditions and properties that connect them with parallel lines, these two can be used to determine each other, and these angles are also the properties of two lines that are parallel. And today we further grasped the properties of parallel lines and the use of two straight lines to judge whether angles are equal or supplementary. We were able to perform simple reasoning and calculations based on the properties and judgment of parallel lines. We really appreciate you watching through Inquisitive Kids, and if you enjoyed this video or found it helpful, please subscribe for more and hit the like button as well. Again, thank you so much for watching through Inquisitive Kids, and we'll see you next time.